Okay, let's pick it up. We did parts A, B, C, and D. Let's look at E and F. At least we might have time for G. We'll find out in this video. Part E. Things get interesting here. I'm going to approach 0 from the right, and it's the square root of x times the natural log of x. Okay. If we try to plug in 0, what would happen? We'd have 0 times, and the natural log of x, as x approaches 0 from the right, there's that vertical asymptote. We'd have 0 times negative infinity. So yep, that is an indeterminate form. But remember that the rule, L'Hopital's rule, is always about a ratio. You have to have a numerator and denominator. We don't have that here. So what are we going to do? We need to rewrite square root x natural log x as a ratio before we can apply the rule. How are we going to do that? Think of it this way. This is x to the 1/2 natural log x. We could write it as the natural log of x divided by x to the negative 1/2. Tuck that 1/2 in the denominator, but if we do, we got to make the exponent negative. Now we've got a ratio, and we can go forward with L'Hopital's rule since they're equivalent. Okay, we already checked indeterminate. We're good. Let's proceed with this. Okay, so using the rule, I'll repeat the limit. X goes to 0 from the right. Now we'll take derivatives. So let's see, derivative natural log x is 1 over x. Derivative of x to the negative 1/2. Negative 1/2 x to the negative 3/2. Okay. So there we are. Before we attempt to plug 0 in a second time, we want to simplify this. Don't try to plug in just yet. It's got to be in its simplified form before we can do that. It could be that we try to plug in again and we get something, some zeros obviously here, maybe even something that might appear to be another indeterminate form, but it's not really an indeterminate form because it hasn't been simplified. So let's work with this a little bit first. Okay. So I'm going to leave the numerator as 1 over x. The denominator, let's write this as a fraction, negative 1 over 2x to the 3/2. Okay. And then I'm going to flip that denominator, multiply, and this is going to clean up pretty well. Let's see, it'll be negative. See, the 2 will be there, and the x's will reduce 3/2 minus 1 x to the 1/2, or maybe I even call it negative 2 square root x. So, well, now, yep, I'm safe to plug in 0, and what do you know? That results in 0. So what happened? Going all the way back to the beginning, there was that tug of war between square root x and natural log x, and who won? Well, the 0 won out. The square root of x was going to 0 faster than this was going to negative infinity. And so these numbers were getting closer to 0 quicker than those were getting big. And so in the end, the 0 won. There we have it. Okay. Kind of similar strategy for part F. The limit as x approaches negative infinity, 5x squared e to the x. So we notice that we don't have a ratio. Actually, probably first thing we should do is make sure this is an indeterminate form. If we plug in negative infinity into x squared becomes positive infinity. So we'll have, and then times 5. So positive infinity times negative infinity into e to the x, e to the negative infinity. E to the negative infinity, if you think way back, where is that headed? Well, the negative infinity means you're dividing. That's going to 0. So kind of a similar case as our last one with the multiplication. 1 is going to infinity, 1 is going to 0. Who wins? Okay, now that we know it's indeterminate, now we can go forward. All right. So we might think, if we do the same style as the previous question, we might say, let's think of this as 5e to the x over x to the negative 2. So one thing to notice, the 5 needs to stay in the numerator. It's only the x to the negative 2 that we're going to drop. Okay. Let's proceed. You know what? Now that I think about it, is this the only way that could be rewritten? Couldn't we have done 5x squared over e to the negative x? Ooh, wow, yeah. Okay, maybe it doesn't matter which one we pick, or maybe it does. I'm going to start with this first one and see what happens. Whatever happens, we'll also explore this. Okay. Let's take a look. 5e to the x over x to the negative 2. So applying L'Hopital's rule, derivative 5e to the x is 5e to the x. Derivative of x to the negative 2, negative 2x to the negative 3. Let's see. If I simplify that a little bit, we'd have negative 5 over 2 x to the third e to the x, right? I simplify. You know what? This approach is not going to work. We need to go with the other one. How do I know at this point that choosing 5e to the x over x to the negative 2 will not work out? It's not that we did anything wrong. Everything here is correct. But look at this new limit compared to the original. This has an x cubed where the original had an x squared. This is harder, or you might say like more complex than the original function or the original limit, because the x cubed. Well, we don't want things to get more complex as we do L'Hopital's rule. We want them to get simpler so that we can then plug in whatever we need to do and get an answer. So if you start doing some derivatives, some of the rule, and it's getting worse, then something is off. This is not the approach. Don't do it that way. Let's approach it with this, 5x squared over e to the negative x. X approaching negative infinity, 5x squared over e to the negative x. Applying L'Hopital's rule this time. 10x, okay, that looks good. And this derivative, e to the negative x, notice there's a chain rule. We'll take the derivative of the negative x, which is negative 1. So this would be negative e to the negative x. Okay. Now that definitely looks simpler. We just have 1 power of x. It's still, e to the x if we put it back in the top. We're moving in the right direction. Let's see, can we plug in negative infinity at this point? If we did, what would happen? We'd have a negative infinity there for x times 10. Here, let's see, e to the negative infinity would be e to the infinity. E to the infinity is infinity, and then that negative, we'd have negative infinity there as well. And I guess we could say those negatives cancel. That'd be true. But that's still an indeterminate form again. So what do we need? We need another L'Hopital's rule here. Another one would be 10 over, and this time multiplying by another negative would turn it back to positive e to the negative x. And so now we can do it. There are no more x's. Putting in negative infinity, e to the infinity in the denominator, 10 over infinity, that is going to 0. We're dividing by bigger and bigger numbers. And so who won out here? Again, it was that 0 that won. This e, that e is hard to beat, you know. That was going to 0 faster than this was going to infinity. The 0, 1. Okay, you guys, I think let's stop here. And we'll do the very last example in the next video.